Hello students and welcome back to Study Room. So today the topic that we're going to be studying is mirror formula and magnification. So now we're going to be using all that we have studied till now, the ray diagrams, where the image is formed, if the image is enlarged or is it diminished, all of those concepts that we have learned, and we're going to use the mirror formula and we're going to find how much the image is enlarged or how much the image is diminished or where the image is formed if you are given the distance of the object from the mirror. All of these things we are going to find out. Okay, so make sure that you thoroughly know the concepts till now or else you would be very confused. Okay, so make sure you remember everything we have done till now. Okay, let's go. So we're going to first see the sign convention for reflection by spherical mirrors. So this is the base. This is basically setting up the base for what we are going to study afterwards just now. Okay, so this is something that is very simple and that you have to keep in your mind before we do the mirror formulas. So this is the sign convention. We call this the sign conventions for using the mirror formulas or for the spherical mirror. So what is the sign convention? Sign means a plus or a minus, right? You know signs -4, -5, or you say -4, -5, or +4, +5, right? So the sign is the plus or minus before a number or a quantity. And convention means how we generally do it or what is the largely accepted way of doing something. Okay, so it would be very difficult, right? If someone says that, okay, the numbers that lie to the right side of 0 would be called negative numbers, and someone else says that the numbers that lies to the left of 0 would be called positive numbers. But that would be very different from what we are studying today, right? So that is why there was a general concept called the number line introduced, which I'm sure you all know very well by now. So in the number system, what was decided that all numbers to the right side of 0 would be called positive numbers and they would carry a plus sign, and all numbers to the left of 0 would be called negative numbers, right? Or negative integers, whatever you want to say. So this was the sign convention decided for number system, so that universally there is no confusion regarding the numbers. So in a similar way, sign convention was decided for spherical mirrors also, so that it doesn't happen that someone says that all images that are formed towards right are positive and someone else says they are negative. Okay, so there is one clear decided way that we are going to study now. So look at this. This is a mirror. What type of a mirror is this? If this is AB, you can see here A and B. If this is your AB and you have kept your object on the left side, then that means that this is your reflecting surface. This part that I'm drawing right now, this area is your reflecting surface. So that means, is your reflecting surface caving in or is it bulging out? It is very clearly caving in. So which type of mirror is shown here? This mirror is a concave mirror here, just in this example. So let's just, what we always do, we just shade the non-reflecting side so that there is no confusion. Great. So what is shown here is, this could also be a convex mirror. Okay, you don't need to get confused that, oh, here it's a concave mirror shown. Is it different for a convex mirror? Absolutely not. It is the same for a convex mirror too. So I could draw the object like this. This could be my AB and my image could be like this, B dash, A dash. Okay, so now as you can see, all of the things that I have told you till now are coming into play. Like I told you that always the alphabet that is near the head of the arrow or near the pointy place in the arrow is the A. A is the alphabet that comes near the pointy end and B is the one that comes near the flat end. So these are all the things that I have told you and are going to be used now. So I hope you remember these concepts. Okay, that's why we have named our object as AB and we have named our image as A dash, B dash. And again, the image was formed downwards or inverted. So we drew the arrow from the principal axis towards the downward side and the head was here. So we named this A dash, B dash. Okay. So I'm going to remove all of this now and we're going to be studying the sign convention. So this figure is very, very important. This is basically the base for the mirror formula. Okay. So what is it said here? The object is kept to the left of the mirror. Okay. Then what is the direction of incident light? You remember when we were initially doing starting ray diagrams, I had said that each point on the object acts as a light source or a point source of light. So that means the light is falling from the object to the mirror and that light is reflected back. Okay, this we all know. And then I also told you that we only consider two rays of lights just for simplicity purposes. Okay, so now here that means that this arrow that it's shown, that says direction of incident light, means that the light is going from the object towards the mirror. So obviously the direction is this way. This is the direction of incident light. Okay, so I'll just put a tick around near whatever we have studied. Okay, object on the left we have understood because it is to the left side of the mirror. Direction of incident light, we know the light is falling from the object to the mirror, so it is going from left to right, and that is the direction the arrow shows also. Next thing is distance towards the left and distance towards the right. Now these two distances are measured from the pole. Okay, so these distances that we are saying towards left or towards right is like from the pole. You can compare it to the number line. So here the 0 of the number line is the pole of the mirror. Okay, so like all distances are measured from 0, like after 0 here like 1, 2, 3 and -1, -2, -3. So similarly from the pole all the distances are measured from here and here. So the pole is basically the 0, and from here we measure all the distances of the image and the objects. So obviously the same concept that we use for a number line, all the numbers to the right of the pole, like to the right of 0, are positive or negative? They are positive. That's why it says distance towards the right is positive. Okay, that means the distance towards the right of the pole are measured as positive, and here as it says that distances towards the left are negative. Like in the number line, all the numbers to the left of 0 are negative. Same concept, okay, same logic. So we have covered these two also. Next thing I see here is head upwards and head downwards. So head again means the pointy end of the arrow. That's called the head of the arrow. Now if you have seen, now I'm going to try and relate this to things that you already know. Like you already know the number line. Similarly, I hope you have already seen the Cartesian plane or the XY plane that we call. So this is the x-axis. We usually mark this as x dash. This is the y-axis and this is the y dash. So this is the 0 of the Cartesian plane, right? So all distances here are on the positive x-axis. All distances here are on the positive y-axis. All distances here are on the negative x-axis. Like similarly, these are, you can think of this as two number lines intersecting like this, right? Okay, so in the two number lines intersecting, basically this is the common 0 point of the number lines, and the x number line lies like this, like a sleeping line, and the y number line lies like this, like a standing line. And like that, here all distances like this are the negative, in the negative direction. So this negative and positive x we've already covered here. The distances towards the right are positive and distances towards the left are negative. That we have covered in the x-axis. Now if we have to look at how the height of the object and how the height of the image is measured. The height, the image and the object are like this, straight. So can we measure this on the x-axis? The x-axis is like this 1, 2, 3, 4, 0, -1, -2. So can we measure this distance on the x-axis? Can we measure this on this axis? No, right? We are going to need a different axis that is going to be parallel to the image and the object arrow to be able to measure how big the arrows are. Okay, so for that we use the y-axis. So here we can see that upward direction is the positive y and downward direction is the negative y. So similarly, coming back to this figure, the head upward means positive and the head downward means negative. Okay, so we have covered this. So a quick recap of this. What did we study? That the pole acts like the 0 of the number line or the 0 of the Cartesian coordinate. And here the sleeping line is our principal axis, and here is the mirror, and all distances towards the right side of the pole are positive, all distances towards the left side of the pole are negative. Similarly, this was on the x-axis. Now, if we talk about the y-axis, all distances upwards from the pole are positive and all distances downwards from the pole are negative. So these four things, where positive and where negative, these four things you have to remember and you have to understand. It's not something that you have to remember. This is just plain logic, okay? And if you keep it relating to your number line concept, then you would never forget it, okay? So for the principal axis, you relate it to the number line, and for the image and object measuring, you relate it to the Cartesian coordinates y-axis. Whichever way you want to remember it, you remember it. But these are the things that you have to keep in mind, okay? So pole के right side पे positive, pole के left पे negative, upwards from the pole positive, downwards from the pole negative. Great. Now that we've learned this, we can move on. Now, this is basically what we have studied and what I have just explained written down in words, okay? So the new Cartesian sign convention says that the object is always placed to the left of the mirror. That was the first thing that we saw. And the light from the objects fall towards the mirror. That's why if the mirror is like this and the object is like this, that's why you remember the ray we take it like this. What is the direction of the ray? Direction is this, right? And after reflection, wherever it passes through, the direction of the ray coming from the object, this object AB is always from left to right. Okay, that's why we say that the light is falling from the object to the mirror. Great. That is the first point here. And the light falls from the left hand side because the object is on the left hand side. Okay. Then all distances parallel to the principal axis are measured from the pole of the mirror. That means, what does it mean when we say that all distances parallel to the principal axis? So when we talk about, like if this is your mirror and this is where you've kept your object and this is where your image is being formed. Say, this is just an example. Okay. So, if this is where your object is AB and this is where your image is being formed, A dash, B dash, then now what is the distance that you have to measure? If you have to measure the distance of the object from the mirror, how do you denote it? You denote it like this, right? You say this distance is the distance of the object from the mirror. Then you say this distance is the distance of the image from the mirror. Can you see this line? Which line is this line and this line parallel to? It's parallel to our principal axis, right? That is why it is saying all distances parallel to the principal axis are measured from the pole of the mirror. So, as I told you, the pole is like the 0. So, all distances are measured from the pole. Like the pole axes are 0 and then to the right side positive and to the left side negative. Second thing is, and it says right here, all distances measured to the right of the origin are as a positive and to the left side of the origin or the pole are negative. Same thing that I told you, like a number system, number line. I'm just adding one more point. Here. All distances perpendicular, this is the sign for perpendicular to the principal axis are measured from principal axis itself. What does that mean? That what are the distances that are perpendicular to the principal axis. Perpendicular means at 90 degree. Look at this figure that I have drawn right here. This figure. What are the lines that are parallel to the principal axis? These two lines that we have already talked about. Now, what are the lines that are perpendicular to the principal axis? Can you see any lines? There are two lines here perpendicular. What are they? They are AB and A dash B dash, that are our object and our image arrows. So these are perpendicular to the principal axis. Right here you can see they are at 90 degrees. So where are they measured from? They can't be measured from the pole. The pole is here. If we measure it from the pole, they'll go something like this. This will be our distance. This is not the distance we want. We want the distance AB. We want this distance AB. So this distance AB and this distance A dash B dash, which is perpendicular to the principal axis, is measured from the principal axis itself. Okay, so we take this point as say 0, and then we measure if it's 1 centimeter, 2 centimeter, 3 centimeter, and so on. Okay, so in case it is perpendicular, like the height of the object or the height of the image, they are measured from the principal axis and not the pole. Okay. Next it says distances measured perpendicular to and above the principal axis are taken as positive. Similarly, like I told you, like the Cartesian coordinate, all distances above the pole or above the principal axis are positive. All below the pole or below the principal axis are negative. Okay, this we have done already. Let's move on. So the mirror formula, this is very, very, very important, extremely, extremely important. It is 3-star important. The mirror formula you are going to use everywhere that you are going to do any numericals. So these are some conventions again that you have to know that will be used everywhere. These are symbols that will be used everywhere. Yeah, so here you can see that the object distance is denoted by the letter U. The image distance is denoted by the letter V. Okay. And the focal length is denoted by the letter F. All small. We never use capital letters for denoting U, V and F. Okay. And the relationship, this is the king formula for you. Like this is the formula that you have to know if you want to solve any numericals related to spherical mirrors. Okay. So the formula is 1 upon V plus 1 upon U is equal to 1 upon F. Okay. And while you are using this formula, the thing that you have to remember is sign always taken into account. What does that mean? It means that whenever you are putting your value of V or value of U, you always have to go back to the sign convention that we studied, and according to that only you can put the values. Like if the object is placed 3 centimeters to the left of the pole. So what is the object distance? We just studied that the object distance is denoted by small u, image distance is denoted by small v, and focal length is denoted by small f. So the object distance small u, I just said 3 centimeters to the left of the mirror. So if you just write u, u is equal to 3 centimeters, wrong. Because I just told you that your u is the object placed to the left side of the mirror. So what did we just study? All distances to the left of the pole. Because we have to measure this distance parallel to the principal axis. Because we only have to measure the height of the image in the object like this, perpendicular. Other distances are measured from the pole. So if you say that it is kept to the left, the object is 3 centimeters to the left, then what is the sign convention? Remember, 0 is the pole. To the left of 0 are negative numbers or positive numbers? They are negative numbers. So our u is not 3, but our u is minus 3. So when you put this u here in this formula, you have to put it minus 3 or according to the question, but you have to put the sign very, very importantly. Okay, moving on. Now, magnification. This is the next thing that comes after the mirror formula. So, magnification produced by a spherical mirror, it gives the relative extent to which the image of an object is magnified. So, you remember that we had written in that table also that we had seen that is the image diminished or is it the same size or it is enlarged or is it highly enlarged. So, all these things that we say, this diminished, enlarged, same size, all this is basically represented by the magnification. Okay, and how? When first we'll look at the formula and then we'll get to know why we say so. So look, the M or magnification formula is height of the image, which is denoted by h dash, divided by the height of the object, or h. So, or you can say magnification is the ratio of the height of the image to the height of the object. Okay, this is a different definition that you can use using the direct formula given. Then the next relation that is given to you for M is V by U. So this is not V by U. There is this small mistake here. This is minus of V by U. So it is H dash upon H is equal to minus of V by U. Again, this V by U, when you put the actual values, you again have to use the sign convention depending on is your object to the left or the right of the pole. Great. So here it says negative sign of the value of magnification indicates that the image is real and positive sign indicates that the image is virtual. Now, what does that mean? So first I'm going to tell you how you will get to know if the image that we always used to say image is enlarged, diminished, same size. How are we going to know? Just by looking at the magnification. Now look, our magnification is given by h dash upon h, which is height of image upon height of object. So say we are given that the height of the object that height of image upon height of object, which is h dash by h. So say that you are given that your object is of 20 centimeter height and the image formed was also found to be of 20 centimeter height. So what does that mean? When you put h dash and h, the 20 and 20 they basically cancel out. So what does your magnification come out to be? Your magnification comes out to be 1, right? So that means whenever your magnification is 1, that basically means when is a fraction value 1? When the numerator and denominator are same. Simple. So the number in the numerator and the number in the denominator are same, which means height of the object and height of the image is same, right? So magnification is 1. So this is for same size. Okay, for same size, M comes out to be 1. Okay, so again, you don't need to remember any of this. Just take one quick example. Say you forget, oh, I can't remember when the magnification was 1. Or I can't remember what is a magnification when object and image have the same size. So that is how you do it. If you can't remember what actually is the size of the image and object when magnification is 1, then you think, okay, if magnification is 1, that means h dash upon h is 1. What does that mean? That h dash and h basically cancelled out and gave us 1. And if they cancelled out, that means they are the same number. So means they are the same size, object and the image. Okay, moving on. Now we look at the next case. So there are only 3 cases that can be, right? It can either be that the object and the image are the same size, or it can be the object and the image have a difference such that the image is enlarged or the image can be diminished, right? Only 3 cases can be there, that the image is same, the image is bigger than the object, or the image is smaller than the object. So we have already seen the same size case. Now we're going to look at the enlarged case. Okay, so again, our M is nothing but h dash upon h. Say, now we are saying that it is enlarged. That means the image is enlarged, which means is the size of the image less or more than the size of the object? Enlarged obviously means larger. So that means size of the image is more. So for example, I take my h dash is size of image, right? So in the numerator, that means the image has to be bigger. So say my image is 10 centimeters big and say my object is only 3 centimeters big. Okay. So what happens here? What is the magnification produced? When we divide this, this is 3 3s are 9. 1 remainder, we put a decimal and 0, 3 3. So you can do this yourself. You will see that M was found to be 3.33. So is this bigger than 1 or is it bigger than or is it smaller than 1? 3.33. Is it bigger or smaller than 1? It is bigger than 1. So basically when M is greater than 1, then our object is, when m is greater than 1, our image is enlarged. Okay. The third case is when the image is diminished. Again, m is nothing but h dash upon h. So help me out. Now you tell me. H dash is image size. H is object size. So here if we are saying that the image is diminished, does that mean the image is smaller or larger than the object? Diminished means smaller. So h dash is smaller than h. So say we say here 2 upon 10. Right? This is the size of the image 2. This is the size of the object 10. So image is smaller than the object size. So it is diminished. Right? So what does this come out to be? This comes out to be 0.2. Right? Or you can cancel this and say 1 upon 5 and it comes out to be 0.2. So is 0.2 smaller than 1 or is it bigger than 1? It is smaller than 1. So that means that when m or our magnification is smaller than 1, then object is diminished. So that is how you can just look at the m and c and tell if your image is same size, if your image is magnified or if your image is diminished. How? You just saw that if m, the magnification is given to you as 1, what does that mean? That it is the same size. If m is given to you as greater than 1, say 2, 3, 3.5, 4, what does that mean? That it is enlarged. The image is enlarged. The image is larger than the object. Third case, what if m is less than 1, say 0.2, 0.5, 0.8, what does that mean? That the image is diminished or the image is smaller than the object. Okay. And say you can't remember, oh, I can't remember what case it was. Was it for enlarged? Was it less than 1 or equal to 1 or greater than 1? So quickly what you do is you will remember this formula, right? M is equal to h dash upon h. You quickly put any two numbers. If you want to see what was it for enlarged, you put any two numbers. You just have to think that, okay, enlarged means the image has to be bigger. So in the formula m equal to h dash upon h, just put h dash as a bigger number than h. You make a decimal, you divide it and you see what fraction you get or what is the number you get and you immediately know, okay. So this is greater than 1, so it is enlarged. Okay, great. So that is how you will remember that was it greater than or less than 1 by just putting the h dash greater than h or the h dash less than h. So immediately you will get the relation of m with 1. So you will get to know is it enlarged, same size or diminished. Great. Moving on. Okay. So one thing that I have to tell you here is the negative sign indicates that the image is real. So I'm going to add real and inverted here because whenever we said that the image is real, we always said real and inverted. And whenever we said virtual, what is it that we said? We said virtual and erect. Okay. So try to use these two words always together. If you say real, always say inverted because in your case, whenever it's a real image, it is inverted. And in your case, whenever it is a virtual image, it is erect. So try to say that. So a negative sign indicates that the image is real and inverted. Why is that? Negative sign means that the image is real and inverted. Say this is the object A, B. What does real and inverted mean? Say our image is formed here. A dash and B dash. So, why is the M negative? What did I tell you just before this when we were doing sign conventions? That these two distances are perpendicular to the principal axis. So, they are measured from the principal axis only. So, this distance is measured in this way, which is upwards from the principal axis. So, on the y-axis, this is the y-axis, upwards. Is it plus? Is it positive or is it negative? It is positive. So that is why here it would be positive, and if it is in the downward direction, it would be negative. So if we get a negative sign in the sign, if the sign of M is negative, that means that the image that is formed is in the downward direction. That means it is inverted. That means it is real. Okay. So you can tell a lot of things by just looking at the M. You can tell by the M number if it is greater than 1, enlarged image, less than 1, diminished image, same as 1, same size image. Negative M, if it is has a negative sign, that means real and inverted. If M has a positive sign, that means virtual and erect. So many things you can tell just by looking at the M value. Okay, let's move on. Now, we are given an example here. We are given this question. So, what you should try to do in your exams is that you should just mark out the things that are important in a question. So, what are the things that would be important in a question? What type of mirror? Whatever the information is given after that also. Is the image distance given? Is the object distance given? Is the focal length given? Is the radius of curvature given? Whatever is given and you have to use in your question, you just mark it out or highlight it in some way. Okay. So, the first thing I said that you have to see what type of mirror it is. So, here it is given that we are using a convex mirror. Highlighted. Great. Now, we use for a rear view in an automobile. Okay, great. We don't need this in the question. It has a radius of curvature of 3 meters. Again, important information. Radius of curvature is given as 3 meters. If a bus is located at 5 meters from the mirror, very important, bus is located at 5 meters. And then what do we have to find? We find the position, the nature and the size of the image. Okay, these are the 3 things that we have to find. So, this was the question given to us. Always, when we are writing an answer, especially when it is a mathematical or any science related answer, especially physics, we should always write the things that are given to us. This makes our answer very methodical and it makes it very easy to solve the answer because you already have everything you need in front of your eyes. Okay, so I am going to write here given. So what is given to us? The mirror is a convex mirror. Great. Next thing that is given to us, radius of curvature. Now, second important thing, whenever you are writing these things, what do you have to always keep in mind? Who can tell me? Whenever you are writing these things, the next thing I am going to be writing is the object distance or the small u. What would I have to keep in mind when writing that? Very good. I would have to keep in mind the sign convention. So to make it easy for me and for you, always draw a small tiny, even if the question doesn't say you should draw a diagram, but before you draw a fair diagram, draw a rough diagram for yourself just in the side margin. Okay, so I'm just going to draw a side diagram here. It is a convex mirror, I know that. Great, this is my convex mirror. Now, in case of a convex mirror, where is the focus? Here or here? On which side? On the right side of the mirror, right? So, my focus is somewhere here. This is my focus. This is called my focal length. This somewhere here is my center of curvature, and the distance from, this is my pole. The distance from the center of curvature and the pole is known as the radius of curvature. What else? We have where the bus is located. That means the bus is our object. So obviously the bus can't be located here because no image would be formed. It would be on the non-reflecting side. So the bus would be somewhere here, and we are given that a bus is 5 meters from the mirror. So say this is a distance of 5 meters. And this distance is called small u. We just learned that the object distance is called small u. Now we come to writing this. So the radius of curvature is given to us. First I'll write the number, then I'll go back to the diagram and put the sign. This is the procedure that you should follow so that you don't get confused. So the radius of curvature is given to me as 3 meters. Great, 3 meters. Now back to the sign. What sign do I put here? Go back to the diagram. The radius of curvature, does it lie to the right side of the pole or does it lie to the left side of the pole? It lies to the right side of the pole. So would it be positive or would it be negative? Think back to the number line. It would be positive. Awesome. So radius of curvature is plus 3 centimeters. I'm going to remove this. Second thing that we have to write is Bus is located at 5 meters. That means object distance. I am writing this in short. You have to write the full thing. Object distance bracket small u is, we have to put some sign here, and 5 meters. Go back to the diagram. Is the object to the left of the pole or to the right of the pole? It is to the left of the pole. So, distance is to the left of the pole, positive or negative? Think back to the number line, negative. So, this is minus 5 meters. Our u is minus 5. Next, what do we have to find? This is given now. To find we write. Like just like we wrote given, we have to also write the to find. We have to find v. Okay, and we don't put any negative or positive sign here because we still don't know where the image is going to be formed. Well, in the case of convex mirror, because you've already done the ray diagram, you know it is going to be formed behind the mirror, but we don't put the sign in front of an unknown quantity. We always get the sign automatically after solving the numerical. Okay, now let's solve the numerical solution. So, the first thing that we know is that the formula that we will have to use is the mirror formula, which is 1 upon v plus 1 upon u is equal to 1 upon f. Now, what all do we know here? Do we know u? Absolutely. Do we know f? It is not directly given in the question, but what is given to us is the radius of curvature is 3 meters. And what is the super important equation or super important relation that we learned between radius and the focal length, radius of curvature and focal length? Go back to this place. Can you see this is your r? And we always said that the same distance that we take between the pole and the focus is the distance we take from the focus to the center of curvature, which means F is the midpoint of PC. What is PC? PC is nothing but a radius of curvature. So we know that radius of curvature is 2 times the focal length, or focal length is half the radius of curvature. Any way you want to write it. So now we want to find F here. This F is what we want to find. So what is F is nothing but R by 2. So we put the value of R with the sign. In this case it is plus. So it is plus 3 upon 2, which is 1.5 meters. So there we have the F that we need. We have U, which is given in the question. Now we solve for V. Awesome. So 1 upon V from this formula here. Now we want 1 V. So we'll just keep V to one side of the equation. We'll send everything else to the other side. So this becomes 1 upon F minus 1 upon U. When we took this to RHS, it becomes a negative sign. You know that. So we put the values here. What all values do we know? We know that F is nothing but 1.5 minus U is nothing but, where is my U? Minus 5. So this is where this minus sign comes into importance. So when you put this here, you don't just put 5. You put minus 5. Okay. Okay. So here we can see that if we take this minus sign up, what happens? This would become 1 by V. 1 by V is equal to 1 upon 1.5. This minus sign, it goes up. It becomes, what does it become if it goes up? If I write it here, 1 upon 1.5 minus, taking the minus sign up, minus 1 upon minus 5. So this minus sign and this minus sign together, they become plus. So this becomes plus 1 upon 5. Right? Next, what do? We have to basically take the LCM of 1.5 and 5. So isn't that very tedious? Would it be not easier if we just multiply these two and then we multiply these two numbers and just add them? What am I saying? I'm saying that 1 by V is equal to, if I just multiply these two, I do 1.5 into 5. So when I do this, what would I have to do? I would have to multiply this first term by 5 and I would have to multiply this second term by 1.5. So what does it become? It becomes 5 plus 1.5. Okay. And when we do this, it becomes 1 upon V is nothing but 6.5 upon 7.5. Okay. So now if we want to find V, what would V be? We just have to take the reciprocal of this number, which is V is nothing but 7.5 upon 6.5. And when you divide it, you get V is equal to 1.15. Okay, so this is the answer that you get. V is equal to 1.15. And now you use your previous knowledge and see, does it match with the answer that we have gotten? We know, okay, in the case of convex mirror, always a virtual and direct image is obtained, and it is always behind the mirror. And if it's behind the mirror, look at the diagram. If it's behind the mirror, what is going to be the sign of V? It is obviously going to be positive because it is to the right side of the pole, right? And what is the sign of V that we have gotten? It is positive only. So it's kind of like you are checking your answer in your brain simultaneously, and it had makes sense. So that is why we didn't put the sign of V initially, even though we knew it was going to be positive, but we always get it from the numerical only. Okay, now we have found the position of the image. We know that the image, so you can write a line here, image is formed 1.15 meters to, or you can just say 1.15 meters behind the mirror. Okay, great. Now what else do we have to find? We have to find the nature and the size of the image. So what does nature mean? That is, it real and inverted, and size means basically we have to find the magnification. So do you remember that I said that we can tell a lot of things just by the magnification number, by the sign and the number of the magnification? You remember? So that is what we're going to do. As soon as we calculate M, we would get to know the nature of the image too. That will make sense in a bit. So we know that our M is nothing but H dash upon H. But here we are not given any information about the size of the image and the object, right? So we are not going to use this formula. We use the second part of the formula, which says minus of V by U. Okay. So here, what is, we put the minus sign. What is V? Our V is 1.15. And what is U? Our U was minus 5. So when you solve this, you will get, so this minus and minus cancel out. So that means our M is equal to, when you solve this, you will get 0.23. So now what is the sign of M? Sign is positive. So go back to what we studied. If the sign is positive, that means that our image is measured upwards from the principal axis, right? What does that mean? So that means, is it like this or is it like this? It is like this because it is measured positively from the principal axis. That means, is it virtual and erect or is it real and inverted? It is erect, it is upright, so it is virtual and erect. So, and what is the other thing that you can see? Is M less than 1, greater than 1 or equal to 1? M is less than 1, right? So the image formed, you can also say this in addition to it. This would make your answer even more technically correct. The image formed is diminished, and you can write that as an extra information. And then you will say, as there is a positive sign in the magnification, that means that the image is virtual and erect. That means upright. And the second thing that you will say is that the size of the image is diminished. Okay. So now you can see how many things you can just tell by the magnification formula. So one thing you've said here, virtual and erect. The second thing you will say that diminished also. And the reasoning for this, you will give that M is less than 1. So that solves your question. Okay.